today we're going to start 7-3, which is triangle similarity. So the first rule we're going to talk about is the angle-angle similarity statement. And that happens when two angles of one triangle are congruent to two angles of another triangle. Okay, so two angles of one triangle are congruent to two angles of another triangle. Then we know that the triangles are similar. Okay, so two angles of one are congruent to two of the other. We know that they're similar triangles. And that makes sense because remember that similar triangles have congruent angles. So if two of them are congruent, we know the third angle is congruent by the third angles theorem. So naturally, it would follow if you had two angles that you would have similar triangles. Okay, and remember they're similar, not congruent, because their sides do not have to be the same. Okay, and then the next thing we're going to do is explain why the triangles are similar and write a similarity statement. So the first thing that I noticed is we were given that A and D were congruent because they're both right angles. And then from there, I can infer from the diagram that these two angles are congruent. Okay, Avery, do you remember what those type of angles are called? These two here that I have marked?
No.
No? Sarah, you remember? No? Go ahead. Vertical angles? Yes, vertical angles. Okay, so vertical angles are going to be congruent. So angle BCA is congruent to ECD by the vertical angles theorem. Okay, I can't just call this angle C because that refers to two different angles. Okay, so that's why I use those three names there. So already I have two congruent angles. So if you know that two angles are congruent, you can say ABC is congruent to DEC by the angle-angle similarity postulate. Okay, and then this is the angle-angle similarity postulate too. So sometimes you'll see it written like this. And then our similarity statement would be triangle ABC is similar to triangle DEC. All right, and then the next theorem we're going to talk about is the side-side-side similarity. So before, when we were using this to prove that triangles are congruent, all three sides were the same. They were equal. But when we're dealing with similarity, they don't have to be equal. They have to be what? Proportional. Okay, so if three sides of one triangle are proportional to three sides of another triangle, okay, then we know that the triangles are similar. So how do we know that they're proportional? Well, that means the ratio of AB over DE would be equal to the ratio of AC over DF, and that would be equal to the ratio of BC over EF. All right, let's go to the next page. All right, so then we have some properties of similarity. So there's the reflexive property of similarity. Okay, so these two triangles are similar to each other. Okay, a triangle is similar to itself. The symmetric property. So if you know that triangle ABC is similar to DEF, then we also know that triangle DEF is similar to ABC. And then finally the, oh, sorry. That will be in a moment. Thank you. Okay, before we get into that, we're going to do the side angle side. Okay, so remember when you have the side angle side, you always have to have the angle in between the two sides. So in this case, it's the angles in between are congruent, and the sides it's in between are proportional. Okay, so AB and DE would be equal to BC over EF. Okay, so again, the angle has to be included. Okay, so we're going to verify that the triangles are similar. And we have triangle PQR and we have triangle STU. Okay, so I want you to take a second and look at those two shapes. Okay, now based on these two shapes, Hope, what do you think we're going to try to use to prove this? Which one of our similarity statements? Okay, yeah, and how did you figure that out? Okay, so you're given the three sides, right? So we aren't able to deduce any of the angles, so we're going to have to use the one that only deals with the sides. So to do that, I have to show that the proportion, that all the sides are proportional. So I'm going to start with side RP here, or PR, whichever you want. Okay, and that would be over side US. Okay, so then I'd have 2 over 3. Okay, and then let's do the other sides as well. I have RQ over, and what would RQ be over? TU or UT? Sometimes what I'll do is, see how these are like upside down from each other? Okay, one thing that you could do is you could redraw this, right? So then you'd have Q at the top. Okay, so RQ is going to be 3 and UT is going to be 4.5. So if I want to find this ratio, we talked about this last week. If you have a decimal, what can you do? Yep, you can multiply by 10. Okay, so it'd have to be 10 over 10. What else could you multiply for this one?
2.
Yeah, why?
Because it's 0.5.
Because it's 0.5, right? So if I multiply by 2 over 2, 3 times 2 is 6, and then 4.5 times 2 is 9. So then isn't this a little bit easier to reduce, right? What goes into 6 and 9? 3. Okay, so then you get 2/3. Again, it would be the same thing if you multiplied by 10 over 10. You'd have 30 over 45. Okay, and you could, what's the biggest number that goes into 30 and 45? 15. So then again, it'd be 2/3. Okay, and then the last one would be PQ over ST. Okay, so 3 over 4.5, which again, that's the same thing that we had above. So we know that that's going to equal 2/3. Okay, so then we can write our similarity statement. So we have PQR which is going to be similar to triangle STU. Okay, and then this is going to be by SSS similarity theorem. Okay, and then for B, we have DEF and HJK. Okay, and again, the first thing I would do is look at my diagrams. Okay, if I look at my diagrams, I want to ask myself, am I going to try SSS, SAS, or angle-angle? This one's going to be what? SAS, because see how you're given a side, and then the angle in between? Okay, so the first thing I would do is look at the angles. So we know that angle D is congruent to angle H, and that's given to us in the diagram. Okay, so both are equal to 70 degrees. Okay, and then the next thing I have to do is show that my two sides are proportional. So I'm going to start with DE, and I have DE over HJ. So DE is 2, HJ is 1, so my ratio would be 2 to 1. And then I'm going to do the same thing with DF over HK. Okay, so DF is 5.8. HK is 2.9. What do I have to do from here? Multiply by 10 over 10. Okay, you have to multiply both. Okay, by 10 over 10. So you'd have 58 over 29. Okay, now remember we're trying to prove that this is 2 over 1 or else they're not similar. What is 29 times 2? 58, right? Because 30 times 2 is 60, and then if you subtracted 2, so this would be 2 over 1. Okay, so then that means that triangle DEF is similar to triangle HJK by SAS similarity theorem. Okay, if these were not the same, then you would just say that they're not similar. Okay, so if they are similar, make sure you say the theorem, and then if they're not, then they are not similar. Okay, so I already started to explain to you part of the properties of similarity here. So reflexive, and then symmetric, and then transitive. So with the transitive property, if you have one triangle similar to another triangle, and that triangle similar to a third triangle, then the first and the third triangle are also similar. Right, so what we're going to do for example 3 is find lengths in similar triangles. So there are two things that we have to do here. It says explain why triangle ABE is similar to ACD. So that's the first thing we're going to do. And then the second thing we're going to do is find CD. Okay, so there are two things we have to do according to the directions. Okay, now let's look at the two triangles that they give us. They give us ABD and ACD. Sometimes it helps to draw them out separately, and in fact that's what I'm going to do, is draw them out so that I have those two triangles and I can look at them separately. Okay, so here's my bigger triangle. Okay, so I have DCA, and then I can label that with X. Now, what would AC be? 12, right? Because 9 plus 3 would give you 12. Okay, and then I have my smaller triangle. Which is ABE. So I have 5 and then 9. Okay, now notice on both of these triangles, they share an angle. What angle do they share? They share angle A, right? So angle A is the same in both of these, right? See how they share this angle here? Angle A. All right, so for step 1, it says explain. So angle A is congruent to angle A by the reflexive property of similarity. Okay, because that's the same angle. So something is congruent to itself. Now we know B and C are congruent. By the right angles theorem, which tells us that any two right angles are congruent. So then we know that triangle ABE is similar to ACD by the angle-angle similarity postulate. Okay, so you need all of that for step 1 because you're explaining. For step 2, it says to find CD. So what we can do to find CD is set up a what? Proportion. So we know that AB over AC is going to equal BE over CD. So 9 over 12 would equal 5 over X. And this isn't the only way that you can set this up and have it be correct. And then when you have that two ratios are equal, whenever you have a proportion, how do we solve this? Cross multiply. So this is when you cross multiply, which we also talked about last week. So if I cross multiply, I'm going to have 9 times x equal to 5 times 12. What's 5 times 12? 60. And then I'm going to divide both sides by 9. What number goes into both 60 and 9? 3. So if I divide them both by 3, I will get, if I divide 60 by 3, I get 20. And then 9 divided by 3, I get 3. Okay, so 20 over 3, which how many times does 3 go into 20? No, not a lot. You have more fingers than how many times it goes into 20. 6, right? With how many left over? 2. So it'd be 6 2/3. Do you guys know what that would be as an approximate decimal? 6.67. Yep, it's 6.6 repeating, so if we rounded, 6.67. Okay, so that's going to be for CD. Okay, so any of those lengths would be acceptable. All right, and then everybody's favorite. Writing proofs with similar triangles. Okay, so we have to remember some of the strategies we were talking about before. So whatever you're given, if it's not already marked on your diagram, you want to make sure you mark it. So you have AB is parallel to DC. That reason is given. And then here it says angle BAC. So I'm going to go ahead and mark that on my diagram. Angle BAC, what would that be congruent to? Okay, so if I have two parallel lines, that's going to create special pairs of angles. What special pair of angles am I going to have here? Alternate interior. Okay, so BAC is going to be congruent to, and sometimes it's easier to mark this down first. Oh, and sorry, this the D got cut off here. This is a D. Okay, so this would be DCA. Okay, and that would be the alternate interior angles, and then they have the theorem there. Okay, now from here it says BEA is congruent to, so BEA, which is this angle here, is congruent to something by the vertical angles theorem. Okay, so Logan, what do you think? What would be the other congruent angle? What's my vertical angle with this guy?
CED.
Yep, except we're going to call it DEC. Okay, so we have these are congruent now. So then, Jared, what similarity theorem did I use to prove those are congruent? Yep. So it's the angle-angle similarity theorem. And like I said, if instead of writing similarity, if you just want to use the similarity symbol, that would be fine with me. Okay, so your homework 7.3, page 474, 1 through 5, 11, 12, 14, 16, 18. If you want some extra practice, you could also try 7 and 15.